There we go.
Hey, good afternoon, everyone. Can you hear me okay? Can you do a handshake if you can hear me okay? Yeah, cool, very cool. Hi, good afternoon and welcome to GRC304, Security at the Speed of Cloud. I'm very appreciative that you can be here with us this afternoon. I know you could be having lunch or maybe the weather's nice outside, so you could be outside having fun, but thank you for being here with us today. This is a 300 level session where we'll show you how security can be a key enabler to your business to help you move fast and stay secure. We have a lot to get through, so let's get cracking. I'm Raisa. I am a DevOps security specialist with AWS Professional Services.
I'm Paul Hawkins. I'm a security solutions architect with AWS.
Could you hear that? Okay, good. But today we're representing a fictitious company, and in the fictitious company I am a dev lead and I am building applications on AWS.
I'm a security architect. I'm facing into a changing world of cloud. I know that the devs are building awesome things, and I'm trying to help them do that while still helping our company stay secure.
And at present, I'm working on my microservices application with this fictitious company. It's a pretty standard architecture. I have API Gateway, Amazon API Gateway for publishing my APIs. I've got AWS Lambda as my serverless compute service, and Amazon DynamoDB that helps me keep my application state. We've chosen to run all of this in a VPC because for our organization, this is a security requirement that we have. Of course, I appreciate that for your organization, it could be very different. What I'm also creating is roles associated with the services that I'll be creating. So in this case, I have a Lambda role for Lambda execution purposes. So I am going to go ahead and essentially deploy that application in my environment. Just switching over to demo. Cool. So I am now in my CloudFormation console in my non-production environment. So I'm actually just going to go ahead and create the CloudFormation stack to begin with because it does take some time, and then we'll come back and actually analyze the CloudFormation template. So let me just go ahead and create. So I'm just going to copy where the S3 bucket URL is. Yep. So just pasting my S3 URL, I'll just also grab the microservices stack, application stack name. I'll just choose some subnets. I'll keep all the default configurations as is and acknowledge, and let's create this stack. Okay, so let's just see that it's populating some events. All right, so as that's populating, let's actually go back and just really quickly analyze the CloudFormation template. All right, so standard microservices architecture, API Gateway, Lambda, DynamoDB, building in my non-production environment. And as you can see, so I'm creating log group, DynamoDB services table, and this is my Lambda execution role. So I have here, basically as per security requirements, I've scoped this down as much as I can, given myself access to logging to specific streams, and of course the DynamoDB table that I am creating with this template. And I'll just keep going down the template so you get an idea. Essentially, this is my Lambda function, and it's operating within a VPC, and these are all my API Gateway resources. So I have basically a REST API with methods post and get, and I'm deploying that within a stage. Okay, so pretty standard, nothing ideally out of the ordinary there. So that's it. So let me just go back now and just see if my CloudFormation stack creation has happened. This does take a little bit of time, so please bear with me. Hopefully it will complete soon. And then we'll have our application up and running. I should have pre-prepared some jokes for you, but I don't have anything, unfortunately. I'm sorry. Let's just try. I'll just wait for this to load a little bit. Okay, creation failed. It says that I am not authorized to perform this action, and it actually has an explicit deny. Cool, this is great. So it turns out I can't create IAM roles. So I guess now I raise an email to security and say, hey, can you please create this role for me?
Excellent, just what I needed, more email. This is clearly a fantastic way of enabling our developers to build applications. This is not something that I'm necessarily going to be paying attention to. I'm not always going to be around when the devs are building stuff. There has to be a better way than this. I want to be able to define our policy as a security organization. I want to be able to empower our developers to make sensible choices closest to the point of the delivery of the application. And I don't want to email me asking me for permission for stuff. So we're going to talk about our journey. This is kind of the amalgamation of a variety of customers that Racer and I have spoken to over the years, from big regulated banks to startups, mid-market. The kind of journey applies to a large amount of organizations. We started off with a realization that we needed to think about cloud security differently. The traditional approach where there was a very prescriptive view of blocking from security, allowing people to do things, wasn't really working. The devs they understand kind of what they want to do in terms of security. They were defining least privileges for the roles that are associated with the Lambda functions, and they're trying to do the right thing, but we still had a blocking process. So we needed a better mental model for how we think about cloud security, how we enable people to move fast and stay secure. And one of the things that's really important in the transformation as you move to a more kind of agile and fast-moving business is the culture of security within your organization. Security is not just the responsibility of somebody with security in their job title. Security is the responsibility of all of the people in your organization. And you can enable this cultural change by building technology solutions which make it easy for people to make the secure choice. Make it fast to be secure as you build and release applications to your customers. So our mental model started off with working out who our customers were and working backwards. So some of our customers are really obvious. The end users of our applications, the people who are going to consume these microservices applications. But also as me as a security person, Bracer is one of my customers. The devs in my organization consume the decisions that I make as a security person. So identifying the internal and external customers is a really important step in understanding who are we actually delivering to. The job of security is to enable the business to move fast and stay secure. It's not to write policy documents and check boxes. We're helping our business deliver to our end customers. And this kind of realization, we thought about it for a while, and we came to an understanding that there's some sort of fundamental approaches that are really important as you build applications in the cloud. One of those things was our approach to service governance. There are a broader range of services in the AWS Cloud, and depending on which development team we're talking about, they're going to be using a different set of services to build applications. And we want to understand those services and understand the security controls that are needed for us to operate them safely and securely. So having a structured mechanism of understanding AWS services allows us to define both the protective and the detective controls that we need in our environment to ensure that people can make choices about the applications they build, but within sensibly defined guardrails. NIST is a familiar framework in the cybersecurity community, and what we wanted it to do was to map our controls to the NIST framework, because it's a really good flow around identifying what we're dealing with, defining some protective controls, moving through detection and response capability, and being able to recover our application and our configuration to a known good state. But when we started looking at the AWS services specifically, we used the AWS Cloud Adoption Framework. So this is a really good way of understanding and thinking about security in the AWS Cloud. It also informs the well-architected framework, which is now a self-service tool that you can use through the console to assess the workloads that you're building in AWS. So if we take these categories from the left to the right, you can follow the same flow if you're a large financial services organization, if you're just a single person spinning up an AWS account with a credit card, the logic is kind of the same. You start off with identity. You need to create some users or federate to an existing identity source to grant people access to call APIs to spin up resources in the cloud. Then once you have the ability to create resources, you want to be able to find out what's going on, so you need visibility. So services like AWS CloudTrail, Amazon GuardDuty, give you that visibility without needing to log on to something and find out what's going on. So now you've got access to call APIs, you've got the ability to have some visibility, you're starting to build applications. So then we're focusing on infrastructure security, so this is how you do your network separation, how you expose your services to the outside world, taking advantage of edge services, things like Shield and WAF for layer 3 and 4 and layer 7 protection, and private link for accessing APIs from within a VPC. And now you've got your application, you want to make sure that you protect your data. So the data protection category can be summed up by encrypt all of the things. And there's a bunch of services in AWS that make it really easy to do that. KMS is a fantastic service. Check a box, put a line in CloudFormation, you can protect data at rest. And then finally, we're talking about incident response. So how do you detect what's going on in your environment, automatically respond to it, and potentially escalate to a human where appropriate? Automation is a fundamental way of helping you improve the security and response capability as you build stuff in AWS. So once we had our kind of mental model and the realization that service governance was actually a consistent way of informing how we're going to define these controls, we kind of built up a hierarchy of the control types that exist in an environment. And you can kind of think of these as kind of product packages delivering to the customers in our organization. So our baseline assurance controls are the things that get pushed into an AWS account every time we build it, using automation, using AWS organizations. These are the controls that are consistent throughout our organization. Things like GuardDuty is enabled, CloudTrail is enabled, the IAM structure that grants just the right amount of permission to developers building in a particular account. Call these our kind of baseline assurance controls. Then we have the AWS service-specific controls. So off the back of our service governance, once we've worked out what the detective controls are going to be, we want to deliver those controls, but only in the areas where particular services are being used. We don't necessarily need to push controls for API Gateway if API Gateway isn't being used in an environment. And the way we do that is dynamic and based on the first use of an AWS service. And then up at the top is application-specific controls. So these are things which are more specific than just the AWS services being used. They are specific for the particular business function. So things that we expect to see from within an application when somebody's building it. So once we had this definition of the layered approach to defining and implementing these controls, we want to be able to deliver them across our environment. And what we want to do is make sure that we're doing this programmatically and automatically. We don't want to be logging onto an AWS account, logging onto the console, manually configuring controls in different environments, because we want to make sure that we're driving consistency and repeatability. So our proactive delivery, which is our bottom layer of the mountain here, has got a series of product portfolios built up of a number of different control types. So when we build an AWS account, before the developers even get access to it, we're bootstrapping it with these proactively delivered controls. Then, when they're working in the non-production environment, say the first time they call API Gateway to create their microservices application, we'll detect this, and using a CloudWatch event bus, we'll trigger the automation to push that set of controls that's appropriate for API Gateway into that particular account, which means that the developers are confident that when they're using services, they've got the detect and respond capability deployed into their account without having to engage security to ask for permission to use it. And then on top of that, where we identify specific business functions or any particular application types, we can choose to push specific controls, still using our CI/CD pipeline, still using automation, into the particular accounts. And this way we can build up the layer of product portfolios that are delivering to the various customer segments who are building applications who are ultimately delivering to our external customers. So we've kind of got a good understanding now of what does the service governance model look like, what are we doing in terms of controls to meet our control objectives, but how does this help with our culture? And what we found is that while the technology really does support a the cultural uplift, because we're empowering people to make decisions about the security of the applications based on our guidance rather than asking for permission. We needed to define some principles to help reinforce the culture. So when people are making decisions, they've got something to track back to. So the first one is seemingly fairly obvious: enable the business to move fast and stay secure. But we thought that it was important to have this articulated as our primary principle, because it reinforces our thinking as security people when we look at stuff like, I've got a decision to make. Coming back to the fact that our role is to enable the business to move fast and stay secure helps us define controls that are fit for purpose and meeting developers where they are. And then when developers are building application, the same principle helps them understand that while they're trying to achieve the velocity to deliver outcomes to our customers in a changing world, they also have a responsibility to ensure that they're staying secure with the things they're building. The second one is standardize, don't centralize. We want to have a consistent set of security objectives and control implementations, but we don't want to have that in a big monolithic blob. We want to have that distributed close to where the applications are. And this helps for a couple of reasons. One, it helps us manage change effectively, because the blast radius for change is limited to just the particular application team. And the standardization helps us have a consistent mechanism for detect and respond. If we have a lot of detective controls which are built up of if then that type statements, depending on which environment they're in, or if we're having inconsistencies depending on one environment or another environment or another environment, it becomes a lot harder to manage. Simplification and consistency and standardization helps us have consistent definitions and consistent responses. It also means that when our people move between teams, because at some point someone's going to move from working on an internet banking application to working on a trading application, for example, the standardization means that the environments are familiar, so they don't have to learn a whole new set of environments, a whole new set of control objectives when they're building the applications. And finally, keep the people away from the data. You've probably heard this a few times over the last couple of days. Our CISO talks about this a lot. Minimizing human access to data is an excellent way of raising your security posture. Taking advantage of automation to make changes, so people are working in a non-production environment interactively. They're committing their code into a code repository, they're using pipelines and pushing into production. Production should be a released environment. There should be no long-term persistent access to production. Ideally, you should be able to instrument your applications, identify problems, pull that information back into a non-production environment, update your application, run through some testing and push it out again. But if you absolutely do need human access to certain application types, deliver this in a programmatic and time-bound way, so that you know that people are only accessing the environments for troubleshooting purposes in a very limited way. So Raisa, what does this look like for developers now?
Well, so the developer experience has improved significantly. I can say so as a developer. So let's go back to our previous application, so the one that I was trying to deploy earlier. As you can see, it actually hasn't changed. I've still got my Amazon API gateway, I've got my Lambda functions, I've got my DynamoDB. We're still operating within the VPC because of security requirement, and I'm still wanting to create my IAM role. So let's go ahead and see what happens when we try to deploy the same. So again, I'm in my CloudFormation console. So essentially, I'm just going to be deploying the same stack. I'll create a new stack because the last one failed, so I deleted that stack. And I'm just going to go ahead and I'll copy the links again. So I've just got my S3 link. And I'll just copy as well my stack name. I'll choose some initial subnets as well. I'll keep the same default configurations. And let's create that stack. Again, as you know from last time, it took a little bit of time to create, so let's actually just have a quick look at our template again, just to make sure that nothing has changed. So as you can see here, API Gateway, Lambda, DynamoDB, in a non-production environment. I'm creating my log group. I've got my DynamoDB table. I'm still creating the same IAM role, and I've essentially scripted done exactly the same way as before to the permissions that I need. I've got my Lambda function. It's operating in a VPC. And I've got my API gateway resources that I've deployed. So my post and my get methods in a stage. And of course my Lambda permission. Yeah, so exactly the same template, nothing has changed. So let's go and see how the CloudFormation stack is going. Almost there, lots of creation in progress. We're creating lots of resources, so it does take a little bit of time. So ideally, we should be able to create this after all the security controls that security put in place, yeah? Not quite. But I do notice that I do have a different failure this time. So I'm not authorized to perform this task. It doesn't say that it's an explicit deny. So I remember why, actually. When security and we worked together, they basically set up guardrails for us. So every single role that we had to create had to have a specific permissions boundary. Let's actually have a quick look at my own role. So I am MH Dev Lead, and on me there is a permission boundary which basically says that I can create roles. So this is a delegated role permission boundary. I can create role as long as I have a specific permission boundary policy attached to the role that I am creating. Yeah, so cool. So now I know what I have to do. So I'm just going to go back and essentially update my template, and I'll try that same create stack operation again. So I actually pre-prepared a diff of the templates just so that you can see that basically it's exactly the same template and nothing has changed, but it's as simple as adding a one-liner to your CloudFormation template. All I have here under my IAM Lambda execution role is a permission boundary that is with the ARN of the permission boundary that this role needs to have. And I just want to show you really quickly that this is exactly the same template. Basically, I'll just do a quick scroll so you can see it's literally just that one liner that's changed and nothing else. And I'm creating exactly the same resources. Cool? Yeah. So same. All right, so now I'm just going to go ahead and actually deploy this. So I've preloaded this in an S3 bucket. So let me just go ahead and grab that. So I'm just going to be deleting that stack and recreating it. I don't know what's happened there. Let me just go back to CloudFormation. Let me delete this stack. So, and then I'll just essentially recreate. Just make sure that it's actually deleted. Let me just go back and confirm, otherwise we'll have some conflicts. Yep, okay, cool. So that's all deleted. Create stack, I'll just put in again, same thing that you saw me do earlier. I'll grab my stack name as well. And I'll just choose a few more subnets. Alrighty. And I'll acknowledge, and then we're on our way. Okay, beautiful. While that creates, let's actually go ahead and have a quick look at the permissions boundary that's on my role. Yeah, so let's analyze that a little bit more. Alrighty, so I have this permissions boundary policy open here. And just let's make sure that this is the same one that obviously is on my role. So MH Dev Lead, and delegated role boundary. Cool. So let's have a look. So we saw that earlier, create role. Obviously, I can create any role as long as I have this permission boundary policy on the roles that I create. I also have some allow permissions here for a bunch of services. And essentially, this is going to provide me the boundary of what I have to operate within. Yeah. However, what it does do is that it denies any editing of the policy, given that the policy is of resource, delegated role boundary, and the other policy that I have to have in every single role that I create. And on top of that, I also am denied any deletion of the permission boundary from any user or role. So say that maybe I didn't quite like what security have done here, and I kind of want to just give myself a bit more elevated privileges. If I go ahead and update, say I'm going to be a bit cheeky and give myself IAM star. Okay, so review the policy, save my changes. Yep. So obviously I can't modify anything because essentially I don't have the permissions to do so. And if I really wanted to go and delete the policy, well, it's attached to me, so let me go ahead and remove it from myself. Yep, I don't have the permissions to do so. So basically what security have done is provided guardrails for me to operate within that I can't change or modify, but what I can do essentially is have the ability to create roles as I need to, as long as I'm operating within these guardrails. So let's just have a quick look and see what the stack creation has come out to be. Do you think that this stack will create? Yes, okay, cool. Well, you can see that on the screen. So cool. Now I've been able to create my stack with all of the services in place. I had 0 interactions with security. Yeah, they've provided me the guardrails. I've operated within them, and I'm basically enabled. I'm underway. So very good developer experience. I'm very happy with that. Let's just have a quick look actually at the role that was created, and just make sure that it actually does have the boundary policy attached to it. So I'll go back to my resources. And my Lambda execution role. Cool. And yeah, so it has the boundary policy attached to that. And of course, you have to have the right permissions as well in place to be able to do the actions that you are allowed, even though you have a boundary permission. Cool. So the other thing that's cool that security have done is that they have deployed detective controls in our environment, right? So they've deployed AWS Config and ConfigRules. And what that gives us the ability to do is see where we are in terms of our compliance levels in our organization at any point in time. Using ConfigRules, we are able to create the desired state versus the current state of our resources in our environment, and also map it back to the requirements that we need compliance-wise in our organization. As you can see here, there are a bunch of rules that have been deployed. Let me just go through the rules really quickly. So basically, there are the baseline controls, which is what Paul was talking about earlier, and these baseline controls are essentially there in every single account, regardless of who is using the account. And these are actually all deployed by security as a pre-armored account. So before any of the services or any application teams have started to use that service. And the ones that he was talking about was GuardDuty, CloudTrail, etc. So these are all the baseline ones that we need to have in our environments. And then on top of this, what we've actually also got are the application-specific controls. So in my application API Gateway, DynamoDB, and Lambda, those ones were automatically deployed as soon as I started to spin up the resource. So this is I guess the on-demand delivery model that Paul was talking about, because as soon as I start to use a resource, only then does it pick up that, okay, I need to be putting those controls in that account as the service is being used. And this way you don't end up with, I guess, control proliferation, and you just have exactly the controls that you need in your environment. The other thing I'd like to show you actually is the CloudTrail. For this specific rule, the CloudTrail enabled one, security have actually also set up a remediation action. So with AWS Config rules, you can actually have remediation action directly from the console. So with this one, it's very simple. You just essentially choose the remediation action that you want, put the parameters that are required in place, and you just save that, and it's just there for you to be able to do remediation. This is using SSM automation documents. And so as soon as you have any level of non-compliance on your rule, you essentially just have one-click remediation there. And it actually does look like I am not compliant for one of my rules. So security does say that for every single application, we have to be compliant with all the rules in non-production before we can promote our application to production, which I think is pretty fair. So I am non-compliant for one of my resources, the API Gateway Private Endpoint Policy Check. I've also just received a notification. Let me just go ahead and check. So essentially what we've also got security set up for us were Slack notifications when anything changes evaluation. So I can see my API Gateway is non-compliant. But the incredible thing, what they've done is they've given me a snippet that I can use in my CloudFormation template that I can turn my API Gateway resource to compliance status. So I'm essentially going to go ahead and update my CloudFormation template. So this is a preloaded template, and I've just made changes as per what I saw on Slack. So let me go ahead again and essentially redeploy, or I'll update the stack this time. I'll just take the link for my CloudFormation template, and all I've done is just made those changes to my API Gateway resource policy. And I'll keep everything as is. And let's just update my stack. And that should be pretty quick comparatively. Almost there. Cool, okay, update complete, cleanup in progress. There you go, so I'm all set. Let me just go ahead and see. Sweet, okay. So I've now received another evaluation status and I'm compliant. That's a pretty cool developer experience. So just before I hand it back to you, basically from the developer side, I didn't have to engage security at all. I've just been provided guardrails. I knew exactly how I had to be compliant at any point in time. And on top of that, I was given notifications to say what I had to change and not change to make sure that my resources were compliant in non-production to be able to promote in production. Pretty happy.
Cool. Thank you very much. And this is the benefit of working together. We've realized that security and the development community are both trying to solve the same problem. We're both trying to get applications to our customers. We're just approaching it from slightly different contexts. So what do we build? If we track back to our NIST framework, in the protect space, we had AWS organizations that was deploying AWS accounts that are containing the default configuration, and we're pushing identity and access management roles and policies which provide the identity-based guardrails, such as requiring permission boundaries when developers create roles that are attached to resources. This means that we've got a consistent view across our environment. We're using organizations to create accounts. We're not manually going and creating new accounts. And we're using service control policies to whitelist the AWS services that could be used in a particular environment. And then IAM for the specific API calls across those AWS services. So briefly, to kind of go through some stuff around orgs and SCPs and IAM. So AWS Organizations allows you to have a hierarchy of organizational units which contain AWS accounts. So you have a master account, which is your payer account, and then you can define organizational units. Dev, test, and prod are fairly common designations, but you may have other things which map more accurately to your business in terms of how you promote code through your environment and what business unit delegation you want to achieve. Under those organizational units are the AWS accounts themselves. And at each level of the organization structure, you can attach service control policies. And service control policies use IAM syntax to provide identity-based controls over what APIs can be called in a given account. So if you just had a service control policy at the master account, it would cascade down to everything. Implementing service control policies at different OUs means the AWS accounts that are in those organizational units will inherit those service control policies. And service control policies work in conjunction with the IAM permissions policies and the IAM permissions boundaries to provide the least privileged intersection of the policies. So, for example, if the service control policy is allowing the use of S3 and EC2, and the permissions policy is allowing the use of EC2 and SNS, but the permissions boundary attached to the role is allowing EC2 and SQS, the net result of that is to allow EC2, because that's the only thing that is enabled through all three of those policies. So within our accounts that we build, we have administrators, because we still need to potentially to make changes to accounts, also running automation, and we also need to be able to have the ability to respond to undesirable change. So what we're able to do is we'll be able to use role-based access control with IAM to grant a policy to the administrators of an environment, which gives them the ability to make changes to some of the services that the developers don't have the ability to change. So things like Amazon Guard Duty, maybe updating the threat intel lists, Secrets Manager, you want to have administrators pushing secrets into Secrets Manager, but devs just consuming them, and making changes to Security Hub, which went GA a couple of days ago, and actual making changes to the config rules were actually acting as the detect and respond capability. And then we have the developers in our environment who have the ability to spin up resources as appropriate for the applications they're building. So they may be using EC2 and RDS within the VPC. They can use IAM roles attached to EC2 instances, as long as they attach the permissions boundary. They may be building serverless applications using API Gateway, Lambda, DynamoDB, as Racer described, and then attaching the roles, but roles within understood boundaries using permission boundaries. So identity as a protective control is a really strong way of providing those guardrails which enables people to work, but within a very known state. Let's dive into the policies that you can use to implement these protective guardrails a little bit. So what you want to do is you want to make sure that no one turns the monitoring off in order to be able to detect and respond, and also to be able to go and understand what's happened in your environment. You want to make sure that you're enabling CloudTrail in all your accounts, sending it to a bunker account. You also want to make sure that people don't stop CloudTrail. So you can use a policy like this one, which has got an effect of deny, and the action is on Security Hub, Guard Duty, and CloudTrail stop logging on any of those resource types. So this is a way of stopping people turning off the monitoring, which if somebody is trying to do something malicious, the first thing they'll do is turn off the visibility. We want to be able to have administrators be able to do certain things that we don't want devs to be able to do, and you can take advantage of conditional SCPs, which is a feature that was released relatively recently. What this means is you can move a lot of your IAM policies, of your kind of security absolutes, up into your service control policies at the organization level. So we want to be able to deny someone to make changes to the admin role. So the action for this example is delete role or update role on the particular role. And the condition is, as long as the ARN of the role is not like admin role. And this means that if you're in the admin role, you can make changes, but if you're outside of that admin role, you can't make changes. And here, as we saw before, is what we need to require a permission boundary on a role. So when create role is called, with the resource of the DevOps role, the condition needs to have a string which is like the permission boundary. And you've noticed there's stars in the permissions boundary string. The reason for this is we have the same set of namespace roles and policies across all of our accounts, and we're able to use conditions such as string-like and ARN-like to pattern match the particular policies and roles, which means we don't have to explicitly have the AWS account ID. This is, again, part of the standardization, not centralization approach, which means that all of our accounts look the same from an IAM perspective. So what do we build for detect and respond?
So for detect and respond, we essentially kept to the same framework here. So the NIST framework that we've been talking to. Essentially, we've gone through the process of identification. So we've said for this specific risk or threat, we have to have these controls in place. So we've been able to identify the control. And then, of course, as Paul's been talking to the protective controls, we've created the protection for that specific control that we've identified. For detect and respond, you're essentially keeping to that same control, but you're creating detective and responsive mechanisms for it. And the AWS services that enable you to do that are AWS Config for detection, and for response you can have automated remediation with CloudWatch events and Lambda, and of course you can have manual today with AWS Systems Manager, as I showed you earlier in the demo. So let's talk a little bit about AWS Config and config rules. So AWS Config is the service that enables you to have a consistent state of your resources. Essentially, it continuously monitors the state as well at any point in time. So you are able to see the relationships between resources, you're able to dive into the history of your configurations, and obviously also the changes over time. And AWS Config Rules is great because it essentially leverages the configuration management of AWS Config, and is able to provide you the logic or evaluation mechanisms behind what you currently want in your organization as the desired state versus your current state. So you're able to essentially turn your compliance requirements for your organization to code and be able to run it and be able to continuously detect and monitor. One thing that makes it really easy, so with AWS Config Rules, we've obviously got 86 managed rules that you can essentially go ahead and start using off the bat today on the AWS Config console. If you are wanting to create your own custom config rules, the Rules Development Kit makes it very easy and simple to do. It's open source, it's available on GitHub, you can go in and start using it today. It's managed by AWS, and of course, if you start using it, give us some feedback because we would love to get your feedback and iterate. It's essentially a CLI wrapping around AWS APIs with high-level commands. It's very simple to start using, and you're able to also seamlessly add it to your CI/CD pipelines as well for continuous deployment. So using the Rules Development Kit, all of the controls or config rules that I showed you earlier, they were all developed with the RDK. But with the RDK, what it enables you as well is to do behavior-driven security development. So what do I mean by that? Well, for the controls that we've identified, what we want to do is basically break down those requirements as scenarios for compliance and non-compliance based on your business requirements. So I want to take you through the API gateway control that you saw earlier, because that was essentially part of the demo as well. This is the compliance scenario for the API gateway control. So given API gateway configuration type is set to private, because again it's operating with VPC endpoints, APIs have resource policies attached containing allow statements, and those allow statements with condition string equals AWS source VPC. And the VPC endpoint has to be the same as per the account's VPC endpoint for API gateway. If all of those scenarios are met, then essentially you get your compliance or compliant control. So similarly, you will have various different compliance and non-compliance scenarios that you'll, in a human-readable way, break down, right, for your control. Once you have that, essentially the next step is to write the tests. And this is where test-driven security development comes into practice. With the behavior that you've identified, you derive the tests based on that behavior. This is in Python. What we're using here is the unit test mock library in Python. And what that enables you to do essentially is mock out the API calls, AWS API calls, and you're also able to assert what your expected result is and essentially run that against the logic of your rule. So in this specific one here, it's basically it's running that against the rule logic and seeing what the outcome is versus the expected outcome. So essentially you're doing unit testing before you've even written the rule. Once you have your behavior scenarios and you have your tests, then essentially it's time to write the rule. Because at this point, when you start to write the rule, you essentially want to be constantly testing to see that your rule is being unit tested and the test cases are passing. So this is a snippet, again, it's in Python, for what actually a custom rule would look like. In the same control for API Gateway, I've just taken a snippet from that, and it's essentially looking at passing through the policy, and it's looking at the policy statement. Obviously, if it has allow statements, and it has conditions, and it has string equals source VPC, then it's going to come back with the gateway evaluation as compliant, right? So I've taken you through essentially the development process. We've done, behavior, outlined the behaviors, outlined the tests, done test-driven development, written the rules, all the unit tests are passing, so cool, that's great. Where to now in terms of automatically deploying it at scale across hundreds of accounts? So for our fictitious company, the accounts are constantly growing day by day, so we need to make sure that all of that is automated. Once you have the rule, obviously a good development practice is that you're constantly committing to repo. Of course, that enables you to have version control as well as a robust peer review process as well. Once you've committed, then essentially that could be a trigger for your CI/CD pipeline. This security CI/CD pipeline has static code analysis. So for CloudFormation, you can use CFN linter, or for Python, you can use open source tools such as Bandit or tools from the marketplace as well. And in the pipeline, what you're doing is you're ensuring that all of the unit tests that you wrote with the RDK are plugged into the pipeline, all of those tests are passing, and all of your static analysis are passing as well. And only once everything passes, then you're able to deploy into a security account using CloudFormation stack sets. CloudFormation stack sets extends the functionality of stacks and enables you to do that across multiple accounts and multiple regions in the single operation. So it's the perfect use case for a security pipeline deploying controls in a security account. And essentially this is an iterative process. So as soon as, if your requirements change or you've had to augment the rule a little bit, you will go back and essentially do the behavior, do the test, and then write the rule, plug that into the pipeline, commit it to repo, plug it into the pipeline, make sure everything is running, and essentially this is how you're continuously iterating and continuously deploying in your environment. So once you've had your pipelines, then this is essentially the account structure that works for scaled deployments of control. Again, this is promoting standardization and not centralization, because what you have here in your security accounts are your Lambda functions that are associated with the config rules. If you remember me saying earlier, you have one config rule to a Lambda function. Essentially, there's a 1-to-1 ratio. So we've separated the Lambda and the config rules. We've put all the Lambdas in the security account so that it's in a tamper-proof environment, and it's only able to be modified, updated, deleted through your CI/CD pipeline. And then we have the stack sets, also the parent stack sets in the security account, and then we have the child config rules in your application account. So as you can see here, your stack set X is related to your config rule X, and your stack set Y is related to your config rule Y. That's the account structure, but how do we ensure continuous delivery of that? So as a developer, say I've deployed API Gateway as a resource. Basically, there's an automated, obviously using CloudWatch events and event rule, I pick up the trigger that I have created an API Gateway resource. As soon as that's picked up, a Lambda function essentially deploys a child stack set to the parent stack set, child stack to the parent stack set living in the security account. And there I have my config rules that you saw earlier in the demo in place. And then it's constantly evaluating. So let's go through a little bit of how the evaluation itself is working, the detect and respond flow. Again, as a developer, I've created an API gateway, and that has triggered an evaluation with config rule. The config rule actually calls the Lambda function using Lambda permissions, and Lambda goes and assumes a role in the application account to assess or run the evaluation logic. And then it responds back the results of the evaluation logic to API gateway. So all of that, again, is abstracted and automated, and it's happening across accounts, which enables scalability. Again, you have the option of automatically or manually remediating, automatic through CloudWatch events and event rule, and manually through systems SSM automation document. But essentially that's based on state change, and your remediation takes place where you slap on the resource policy or modification to a resource policy to API gateway. And as you saw earlier as well, that also triggered a notification change, and that was also automated using CloudWatch events and event rule, which triggered a Lambda function, which then notified me in Slack, hey, I'm still compliant or I'm non-compliant. So this is essentially how we've been able to continually iterate and always ensure that we are staying compliant, because we've taken the humans away as much as possible, and we've built automation as much as possible into our non-production and production environments.
Thank you. And from an organizational perspective, we're able to enable our people, both enabling security people to be more optimistic about security, not looking to cloud and go, this is different and scary. We've been able to educate our entire business around what we want to do to ensure that we meet the requirements of our broader risk community and to deliver excellent value to our customers. And we can provide monitoring and feedback, so we can identify which of the dev teams are working really well, which of them are able to move fast and deliver security controls, and find out what they're doing well and move that across our environment into other teams. So that virtuous cycle of iteration, education, and enablement really helped our whole organization. So why is this whole approach good? There's a bunch of different stuff we talked about. So from my perspective, from the view of security, it's automated, which means it's consistent and repeatable. We're not relying on humans to follow runbooks, and automation functions 24/7. It doesn't get grumpy when it's paged at 3 in the morning. We have visibility. We can use the tools available in AWS, such as CloudTrail and GuardDuty, to get better visibility into our applications and into our environments to make informed decisions. And it's codified, and that means that it's articulated, it's stored in code repositories, and it can be syntactically and programmatically assessed, rather than having us write a Word document and then somebody interpret those requirements and apply that to some code. So why do developers like it?
Well, Paul, the developers like it because, firstly, I've had zero interaction with security through all of the deployments that I've done. It's fully automated, it's fully hands-off, and that works really well for me. I get constant visibility, right? At any point in time, I can go to the config rules console, I can see what I'm compliant or not compliant with, and on top of that, I have Slack messages coming through that says if my compliance evaluation is changing. And I'm being also told what snippets to use to be able to constantly remain compliant. And everything is codified. If I, at any point, didn't quite understand what my compliance requirements were as a developer, I can just go and look at the behavior description, understand the requirements company-wise. I could go and look at the tests and also the rule logic and see what I need in my application and in my infrastructure, which will make sure that I am compliant.
The observant amongst you may have noticed that security people and developer people like it for exactly the same reasons, because we're all trying to solve the same problem. We're all trying to get applications to our customers. So we went through this journey. We uplifted our security posture. We uplifted the way we built and released and secured applications so we could increase the velocity of our business, but also raise the bar for security. So how can you do this? So aligning around product teams is really useful, whether it's product teams for the applications that you're exposing externally, or product teams for your AWS platform team, building capability that people can consume. Get the governance model for your organization right. Understand how you evaluate AWS services for above-the-line controls. Work out what are the things that you need to define in your account automation that will enable your developers to work within those guardrails, make decisions closer to the point of delivery of applications, and provide them fast feedback. You can get started now. Racer spoke about the RDK, but there's some links here which you can use to get started. So there's the AWS Security Workshop site, which has got a range of self-paced labs and guidance around the things we've talked about today. So there's a permissions boundary workshop, there's a threat detection and response workshop, there's data protection workshops. Use the well-architected framework to understand the workloads that you're building in AWS. The well-architected GitHub repo has got a whole bunch of code snippets for deploying secure configuration into your environment, and there's another learning path in there. And all of the things that Racer talked about around continuous assurance are available at that link, so you can see what the multi-account, on-demand delivery of controls actually looks like. Thank you for your time. Hope you enjoyed the talk. Go forth, enable your business, and be secure.